Okay, I'll get started. I wanted to present about Kubernetes. At my previous employer, I already worked with this system, and I'm quite enthusiastic about bringing this to the current customer that I'm working on, which is Vakantielei. And also hoping to put Kubernetes on the map for Kabisa for the parts that it isn't yet. Well, as it states, it's a container orchestrator. Well, it doesn't exactly say that, but that's what you mainly use it for. The main goal is I expect most of you to be familiar with Docker, because I'm not going into the Docker internals this presentation. I think my phone is telling me something. Sorry about that. There is some YAML involved, because, well, Kubernetes in itself is quite YAML heavy. I also expect you to bear with me through that part. Well, okay, hi, I'm Sjuul. A bit about the presentation. I want to first address some basic concepts for Kubernetes. It's quite heavy on the concepts, especially in the beginning when you start with it. And what I'm going to use for this presentation is the quotes application that I've built during my during the process that I came on board here, whether or not I was a decent programmer. I was told I was the first one who had built an entire cluster for just a quotes app. So that's a nice note for me. Just a bit context. It's a project started by Google. Google runs about 2 billion containers every week. Okay, let's be honest, quite a few of them will be batch jobs or short-lived containers. Kubernetes is actually an open source spin-off of their internal Kubernetes edition. It's called Borg in there. And you can see it as a cluster operating system. This is how people at Google also think about it. You've got multiple containers and you want to make it more resilient to production stresses, to failures, and of course, for scaling reasons, it's interesting. I'll dive into the parts of the clusters first, because it's quite terminology heavy, as I said. The main parts are, of course, the cluster itself, which is a collection of nodes, and I think of a node as a VM. Of course, it can run on bare metal, but in most situations, it's mostly in the cloud or in a VMware environment if you're thinking about on-premise solutions. The master is actually a collection of a few running services. You can run a single master, but in default, you would run a cluster of at least 3 nodes who maintain a quorum. The pod is for most people the newest term, I would say. You could think about a pod as a single host, but it's a collection of containers which share their IP address for simplification purposes. And the namespace is a way to segregate your cluster into multiple zones, if you will, or, well, namespaces is quite a good term in and of itself. You could segregate production from development, although in my own experience, we separated our production cluster and our development cluster so that we don't have any noisy neighbor effects where one container would utilize all resources or a lot of resources on a single VM, or in the Kubernetes terminology, a node. I'll put those concepts in a picture here. Of course, your cluster, which is the total aggregate. You have in this picture 2 running nodes, and what's new here on this picture is a kubelet, which is responsible for running the pods that the master has determined that should be run on this node. It's just responsible for spawning the pods. And as I said, the pod is a collection of containers. And when you're used to Docker, you would have you're used to running a single container, and you're running, probably if you're using Docker Compose, you have multiple containers running and you share a network between them if you want to share something. Kubernetes allows you to put logical units together. Say if you have a web server and a database in a container, and you know that those are probably best always deployed together, you could put those in a pod. For normal reasons, I would make a separate deployment for a database and a separate deployment for web, but I just wanted to give an example of how you could put some pieces together. Then I just mentioned the term already. There are several different ways of running your containers on your cluster. Let's call this a deployment. And usually you say, I want so many containers from this image running on so many machines. There are some options where you could say, I don't want these containers together, or but I'll not go into those details during the presentation. I have some of those examples in my YAML files. This is one of the main reasons to me as a developer. I don't want to think about running VMs. VMs are for me something ephemeral, something you should be able to throw away. You don't want to store your state in a VM. I don't want to think about the infrastructure, especially if I'm a developer. Preferably I'm infrastructure as agnostic. And when you're running Docker containers and you want to run those on multiple machines, you're soon going to miss a few features from Docker itself. I know that Docker Swarm can offer quite a few of these features in and of itself, but to me, there was a race between Docker Swarm and Kubernetes, and I don't see Docker Swarm winning anymore, or never actually have seen Docker Swarm in a better position than Kubernetes was. What you what you're of course missing is multi-machine deployments, some part of DNS across your machines. Scaling is, of course, when you're a single machine, a bit limited. Multiple users, failure tolerance. You can specify how Kubernetes should handle failures. It helps with monitoring, although that most monitoring is usually done in Prometheus, which I actually haven't implemented yet. It helps with logging through, also just like that monitoring can be held through system containers. It helps you with high availability, is something that often already comes with multiple machine deployments, but it helps you also with the deployment life cycle in and of itself. It helps, for example, with running migrations, or defining how many parts of a certain deployment are allowed to be gone. Let's say it crashed, or the server is updating, and you want to specify, well, for my database cluster, I want to have at least 2 or 3 nodes up and running. Or you could do it on other way around. You say, for my database cluster, there's at most 1 instance missing. This will impact when your servers are going to update, for example. When you have a newer version of Kubernetes and you want to update your nodes, and it's going to see whether or not it can move a certain container to a different node. So if you only have 2 nodes and you specified somewhere that at most one pod of a certain type can run on a single node, and you are going to update your 3rd node, and you have 3 pods, it can't actually deploy the last node if you just specified every node can have a maximum 1 of these pods on them. These are the main kind of deployments. Yes.
So imagine that you have such a situation that you cannot move a pod to a different node to update the node. Does Kubernetes detect these errors?
It will mostly hang in some sort of catatonic state. Usually you would have made sure that there were enough nodes present beforehand. A usual migration would have been that you first provisioned an extra VM on which new pods could land. Perhaps that VM would already be in the newer Kubernetes version. Then you decommission one of the running nodes, and pods are moved over to probably the new one, but it's Kubernetes who decides. Unless you specified it up front, it's Kubernetes who specifies where the pods are going to run. There are a few main deployments within Kubernetes. Replica set is, to me, one of the most simple ones. Replica sets are actually deployments where you don't have any state in your pods. So if you shoot one of them in the head, the users wouldn't notice that something is off. The way the load balancers in Kubernetes work is that service, or in this case a pod, registers itself to the service, says, hey, I'm fine to handle load for this service, and then it automatically receives requests from whichever application is running. Stateful sets, well, if you first have replica sets which don't have any state, stateful sets have been introduced after that replica sets have been introduced into the Kubernetes, and those are usually machines that if you restart them, you want to store your data. You want to have your data again, and stateful sets are usually numbered. Let's say numbered pods. So if you're running a Postgres cluster of 3 nodes, you want to be sure that the same disk attaches to the same pod when it starts. Sometimes you really need this in order to have some consistency within your application. Daemon sets are actually deployments that run on every node. Let's say you want to have log shipping, and you run a daemon set which can ingress the logging data and ship it towards your central logging system. Mostly daemon sets are for monitoring purposes. I've implemented one in my example as well, where I want to be sure that I have a Docker registry, and which would be available to all nodes on the local IP address. So I used a daemon set to provision that one. Jobs and cron jobs are also possible in Kubernetes. You can actually just specify a cron line and the container that should run. This I've used for doing backups of certain data in our previous employer. Service is where you have, for example, a TCP/IP port, which you want to load balance to your pod, or just a simple point where the pods can talk to, and say your Postgres database runs outside of your cluster. You could have some proxy service running inside your cluster, to which the internal services could talk. Then there are config maps and secrets, which are in essence function the same way, where of course secrets are not obvious. You cannot see the contents of the secrets that easy. Although in my experience, I often miss the added value, because in order to decrypt the secret, you have to have the key somewhere in your cluster. So it's not that secret after all. This is the main dashboard within Kubernetes. Most of my work usually is on the terminal. There is a dashboard, but I often think that it's kept so dumb that you would prefer the terminal client, which is kubectl or kube control, or well, it's spelled kubectl. Kubectl is the pronunciation that I use. So I built an example. I had an example application off the shelf, the quotes application that we usually write when we apply at Kabisa to come and work here. What I did was I had I didn't specify this icon actually. It's an ingress which does some routing across, which is, well, it looks like a reverse proxy where you, like Nginx, where you specify if a request for this and this domain comes in, you have a underlying service to which you reroute your request to. What I built in my quotes application, I built two Python applications. One in AIO HTTP, which is a asynchronous web server, and one in Falcon. And I specifically built one in Falcon because I knew that it was, well, used actually somehow, because there was a presentation at Kabisa about Falcon. So I wanted to implement that in my application. Those two applications have both a task to serve quotes from some source. The AIO HTTP application gets the quotes from Reddit. There's a JSON API which it speaks to, and the Falcon application goes to just a web page and scrapes through XPath or CSS selectors, I'm not sure. It scrapes those values from the website. What I wanted to show during my application was that you can have a single service with multiple backends on them, which work as a seamless service together. So when a request comes in from above, it could go either way to the backend services, if you will. And I made sure that every backend server was provisioned with at least 2 replicas to show that even if one of them crashes, it would keep running. Here is the YAML part that's coming, so bear with me. I've highlighted the main parts where you would configure the parts of your replica set. Well, of course, you're going to specify the image name. I've made an internal service from which this Docker container can be pulled. So it's the Docker registry in this solution is a Docker deployment as well. So I wanted to make something self-contained, not have the user go to the internet to run the solution. By the way, how much on time am I?
23 minutes.
Left or in?
In.
Okay, so I have 7 minutes left. Okay, I'll have to make some speed. A replica set with, of course, the number of replicas. I've also implemented a stateful set for. Wait, that shouldn't be right. Nginx is not really stateful. Well, in my application, I've also implemented a stateful set for the database. Well, and what I wanted to show is that you claim some piece of storage from Kubernetes, and you can then mount this storage inside the VM, or in the container, I mean. A service where you specify that you're going to host on port 80, and where any application that has, or any deployment that has a label app is Nginx will be added to this service. Like I said a few slides before, what you as a service can say, as a pod can say, I want to be able to serve for this service. This is the selector that accomplishes it. And this is to me the main part of Kubernetes, which gave me an aha moment. Before, I was always thinking, what should I build so that when I make something new, some microservice, and how do I make the rest of the cluster aware of this? Make the rest of my total application aware of this? I would perhaps implement something with pub/sub, or create some single point of failure, or actually had to implement some distributed system in order to achieve this. And suddenly, when we started using Kubernetes, this problem was solved before we actually even started tackling it. I noticed, oh, this is how you run a service, and suddenly everything fell in its place. If I were to express one major thing about this presentation, it would be that it really helps you to set up a microservice architecture without adding a lot of plumbing inside your code base for it. The plumbing is in the cluster definition. Then you have an ingress. Ingress, as the name states, this is where your requests come in. And this is where I split the HTTP calls for my quotes application. I specified something that I wanted to store something, so I made a list of quotes I liked in the application, and I made a service for likes. I said this is running also on port 8080. Then the service that serves up the random quote is running with a different backend and on 8080. And then I built a small React front end, which was served by Nginx, and is running on port 80 internally. Yeah, you have different kind of services, but for time reasons, I'm going to skip ahead. Add-ons, I'll skip. I'll go to, and I hope that the resolution is fine. I'll first show the solution. I had to add some DNS record, or well, I had to update my host file so that I'm running on Minikube, which is a single VM Kubernetes implementation you can install. It's actually just brew install Minikube, and it will down if you've got VirtualBox installed, it will download a VirtualBox image and run your cluster in there. I've added a button where I could click on and get a new quote, and I could add a button where I could save a quote. Oh, first get a new one, save it to show that it's stored in the database. I'll refresh it. The fun thing is I can go to my terminal. I'll first show you what's shown here. I hope it's readable for you all. These are the containers that or pods that I'm running. Inside the Falcon quotes container, I added an extra memcached server, just to show that you can combine multiple containers inside a single pod. You can see that I've created the cluster in the weekend, just to be sure that I would have time enough. And I wanted to have the cluster running beforehand so that I wouldn't have too many demo effect problems. You can see how many times service has been restarted, whether or not it's running. These are the services that I'm running. Usually, when you have, for example, I've made sure that the Docker registry was available on port 5000. Usually you would get an external facing IP address in your cloud provider. And of course, I've implemented some insecure Docker registry. So to me, that isn't really necessary. It's just for demo purposes. But that's the reason why you see here that the external IP is pending. Usually, this is something that Kubernetes claims for you with your cloud provider. Then this is the ingress that I'm running. Usually you would have an external IP address for it as well. And what I wanted to show, for example, is that I can throw away the database. I haven't done it last weekend, but I'm quite confident that if I throw away the database, that the stored data is saved so that when the database starts up again, I can retrieve those quotes that I obviously liked. Kube control delete pod, and I specify the pod. And because I've said that there should be a stateful set, the stateful set controller will make sure that there's at least one of those running. And I hope that the quotes are back already. I hope that I can show you that it's gone when the database is actually gone. No, it's running already. I'm not fast enough to show it to you, unfortunately. Yeah, how much? I think we're through on time. I think we're through.